A valve is a device that control, regulate or direct the flow of fluid by opening, closing or partially obstructing various passageway within a system or process. The valve serves various functions within the piping system, such as starting or stopping flow based on the valve state, throttling the fluid flow, controlling the direction of fluid flow, regulating flow and pressure within a piping system, relieve pressure or vacuum from the piping system. Different types of valves serve these functions, and how they do so can vary mechanically. Therefore, these valves can be classified or categorized based on function, end connection, how it operates, types of actuator it used. Based on functions, they are classified as isolation valve, to isolate or cuts the supply of fluid when needed, control valve, to regulate the flow of fluid, pressure and vacuum relief valve, to prevent overpressure and vacuum within the system. Based on end connections, they are classified into screwed or threaded ends, flange type ends, butt welded valves, socket welded valves, wafer and lug end construction. Classification based on how it operates, open and close, are linear motion, rotary motion, quarter turn. Classification based on actuator used are electric motor, air, hydraulic fluid, or solenoid, etc. Common types of valves, their applications, advantages and disadvantages. Gate valve. The gate valve is one of the most common type of valve that uses linear motion to control the flow of fluid. They are either in a fully open or fully closed positions. They are used in all fluid service functioning as air, fuel gas, feed water, lube oil, steam, hydrocarbon, etc. Different types of gate valve include solid wedge gate, flexible wedge gate, split wedge or parallel disc gate, outside stem and yoke gate valve, inside screw valve. Solid wedge gate valve, it is the most common used in plants because of simplicity, strength and very much flexible to install in any position. It is suitable for almost all liquids and it is practically for turbulent flow. Flexible wedge gate valve, this is a one-piece solid disc with a cut around the perimeter, to improve the ability to correct mistakes or changes in the angle between the seats. These cuts vary in size, shape and depth. A shallow, narrow cut or wedge perimeter gives less flexibility but retains strength. A deeper and wide cut on wedge perimeter gives more flexibility but compromises the strength. Split wedge or parallel disc gate, this consists of two disc construction, which sit between the tapered seats in the valve body, and holds together with the help of a special mechanism. The split disc can be in a split wedge shape or parallel disc type. Parallel disc type are spring-loaded, so they are always in contact with seats, and give bi-directional sealing. Split wedge is suitable for handling non-condensing gases and liquid at normal and high temperature. Outside stem and yoke gate valve, also known as rising stem of gate valve. This means that when the handle is turned, opened, the stem will rise above the handwheel of the valve. This is because the handle and the stem are both threaded so they interact together. A yoke is an integral part from a rising stem valve and is mounted to the bonnet. It is one of the valve used to control the flow of water to fire sprinkler system. Inside stem or non-rising stem, there is no upward stem movement when the valve is opened. The stem is threaded into the disc. As the handwheel on the stem is rotated, the disc travels up or down the stem on the thread, while the stem remains vertically stationary. Advantages of gate valve. Gate valves are ideal for nearly all fluid services. Provide superior sealing performance. Suitable for use in pipelines where the flow direction may change. Disadvantages of gate valve. Gate valves open and close slowly. Gate valves can be prone to scratches. Not suitable for high pressure implementations. Globe valve. This is a linear motion valve that are primarily designed to stop, start and regulate the flow of fluid. Globe valve are extensively employed to control flow. And other stopper occurs at a place where it have to control the fluid flow, and also take into account the leakage and tightness of the system. There are three types of globe valve: T pattern or Z body type, Y body type, angle pattern type. T pattern or Z body type, this is the most common body type, with a Z-shaped diaphragm. The Z-type globular body is designed to consider and simplify the problem in manufacturing, installation and repair. T-pattern globe valves are used in applications where pressure drop is not a concern, and throttling is required. Y body type, this is designed to solve the high pressure drop problem in Z-type valves. The Y-type seats are angled at 45 degrees to the axis of the pipe. They can be cracked open for long periods without severe erosion. Angled pattern globe valve design. These valves are able to turn the flow of fluid direction by 90 degrees, without the use of an elbow and extra weld of pipe. Fluid flow occurs with a single 90-degree turn. They have a slightly lower coefficient of flow than Y-pattern globe valves, and are used in applications that have periods of pulsating flow. Advantages of globe valve. Good shutoff capability. Easy to machine or resurface the seats. Can be used as a stop-check valve. Disadvantages of globe valves. High pressure drop compared to a gate valve. Requires greater force or larger actuator to seat the valve. Throttling flow under the seat and shut off flow over the seat. 3. Check valve. Check valves allow the flow to pass in one direction. They are used to prevent the backflow in the piping system. These valves are typically self-activated, allowing the valve to automatically open when media passes through the valve in the intended direction, and shut off should flow reverse. Most common types of check valve: swing check valve, piston check valve, lift check valve, dual plate wafer check valve. Swing check valve. A basic swing check valve consists of a valve body, a bonnet, and a disc that is connected to a hinge. It is used in low fluid velocities and where flow reversal is not continual. The disc swings away from the valve seat to allow flow in the forward direction, and returns to valve seat when upstream flow is stopped, to prevent backflow. Lift check valve. The seat design of a lift check valve is similar to a globe valve. The disc is usually in the form of a piston or a ball. A lift check valve is to be placed in a horizontal or vertical position, and are particularly suitable for high pressure service, where velocity of flow is very high. Piston check valve. This type of check valve is known as a plug check valve. It operates by controlling the flow of fluid in a piping system, utilizing the linear motion of a piston within the valve chamber. Sometimes the piston has a spring attached, which helps stay in close position when not in use. Dual plate wafer check valve. The dual plate wafer check valve employs two spring-loaded plates, hinged on a central hinge pin. When the flow decreases, the plate close by the action of torsion spring, before flow reversal takes place. Advantages of check valves. Prevent reverse flow while typically requiring no external actuation. Maintain pressure. Most can be used horizontally as well as vertically. Disadvantages of check valves. Inability to determine condition of the valve and its status. Can't be used with pulsating system. Closing element may slam close, causing damage and excessive wear. Ball valve. A ball valve is a shut-off valve that controls the flow of fluid by means of a rotary ball having a bore, predominantly equipped with quick-acting 90-degree turn handles. The ball spigot is lighter and smaller in size and rating compared to gate valve. Common types of ball valves: standard ball valve, hydraulic ball valve, flanged ball valve, vented ball valve. Standard ball valve. Standard threaded ball valve consists of the housing, seats, ball, and lever for ball rotation. They include valves with 2, 3 and 4 port, which can be female or male threaded or a combination of these. Hydraulic ball valves. They are specially designed for hydraulic and heating systems, due to the high operating pressure rating, and hydraulic and heating oil resistance. These valves are made of either steel or stainless steel. The seat also make hydraulic valves suitable for high operating pressure. The seats of these valves are made of polyoxymethylene, POM. Flanged ball valves. They are characterized by their connection type. The ports are connected to a piping system via flanges, that are usually designed in accordance with a certain standard. These valves provides a high flow rate, since they typically have a full bore design. Vented ball valves. They look almost the same as the standard two-way ball valves when it comes to their design. The main difference is that the outlet port vents to the environment's enclosed position. This is achieved by a small hole that is drilled in the ball and in the valve body. When the valves closes, the hole line up with the outlet port and release the pressure. This is useful in compressed air systems, where depressurization provides a safer working environment. Advantages of ball valves. Open and close quickly. They are manufactured in different sizes and shapes, providing flexibility in selection. Compared to other valves, they are controlled with less force. Disadvantages of ball valves. Cannot be used for throttling. Prone to cavitation. not suitable for slurry application due to cavities around the ball and seats. Butterfly valve. A butterfly valve is a mechanism that regulates the flow of material within large pipe diameters by the quarter-turn rotation of a disc. It also helps in regulating flow start. Butterfly valve is ideal for tight spaces thanks to its wafer-type design. The butterfly valve gets its name from how the movement is similar to a wing for flight. Types of butterfly valve. As per disc closure design, they are concentric butterfly valve and eccentric butterfly valve. As per piping connection design, they are wafer type, lug type, double flange butterfly valve. Concentric butterfly valve, also known as zero offset butterfly valve, is the most basic type of butterfly valve design. The stem passes through the center line of the disc. The concentric butterfly valve is also called resilient seated or rubber seated, because it relies on the flexibility of the seat rubber to efficiently seal the flow when closed. Eccentric butterfly valve, also known as high-performance butterfly valves, the stem does not pass through the center line of the disc, but instead located offset from the center, according to the categories of double and triple offset valves. The valve is called single offset butterfly valve when the stem is located right behind the center line of the disc. It is called double offset butterfly valve when the stem is located behind the disc with an additional offset to one side. Wafer-style butterfly valve, the most economical version, and it is sandwiched between two pipe flanges, and the flange bolts surround the valve body. The pipe flanges are connected through long bolts that cross the entire valve body. The sealing between the valve and pipe is done by using a tightly fitted seal along with a flat valve face on the downstream and upstream sections of the valve. Lug-type butterfly valve, they have threaded lugs outside the valve body. Two sets of bolt connect pipe flanges to each side of the bolt inserts without nuts. This enables the disconnection of one side without affecting the other for dead-end services. Double flange butterfly valve. The double flange butterfly valve have flanged end on both sides of valve. The valve is connected to piping flanges through bolts. The unique feature of this valve is its adaptability for lined pipes due to negligible disc protrusion beyond the body laying length. Advantages of butterfly valve. Butterfly valve are easy and fast to open and close, relatively inexpensive and cost-effective, well suited for handling slurries or liquids with large amount of suspended solids. Disadvantages of butterfly valve. Throttling service is limited to low differential pressure. Disc movement is unguided and affected by flow turbulence. The disc of butterfly valve is always present within the flow. Therefore, a pressure drop is always induced in the flow, regardless of valve position. Needle valve, typically used in small diameter piping system, when fine accurate flow control is needed. The needle valve is similar to a globe valve. Its biggest difference is that its disc looks needle-like. Needle valve have a slender, tapered point at the end of the valve stem, that is lowered through the seat, to restrict or block flow. Fluid flowing through the valve, turns 90 degrees and passes through an orifice, that is the seat for a rod with cone-shaped tip. Advantages of needle valves. They can be used for throttling purpose. The flow control at a low rate is very accurate. They are used as bleed valves for hot water heating. Disadvantages of needle valve. High risk of clogging because of the entrained solids. There is a high pressure loss in the needle valve because of the high restriction of fluid flow. They can be used only for low flow rate piping systems. Plug valves. A plug valve is a quarter-turn rotary motion manual valve. These valves control flow using tapered or cylindrical plugs. Plug valves offer a straightway passage through the ports, so that fluid can flow through the opening plug with a minimum of turbulence. Flow can be in either direction with fully opened or fully closed. Types of plug valves. There are 4 types of plug valves. They are lubricated plug valves, non-lubricated plug valves, eccentric plug valve, and expanding plug valve. Lubricated plug valve. This valve uses lubricants or sealants to reduce friction over a wide range of operating pressure. The lubrication film, which is used between plug and body, provides a seal, and that requires periodic lubricant injection. Non-lubricated plug valves. This plug valve is usually used for lower pressure lines. This valve contains an elastomeric body liner or sleeve installed in the body cavity. Non-lubricated plug valve employs a tapered or cone shape which works as a wedge, and tends to press the sleeve against the body. Thus, the sleeves reduces the friction between the plug and the body. There are three types of non-lubricated plug valve: lift-type plug, elastomer sleeved plug, fully lined plug. Eccentric plug valve. This type of plug valve design uses a half plug. It is advantageous for application that need a higher seating force and minimal friction from open to closed conditions. They are basically used for flow control and isolation services. They are used in clean and dirty water, sewage, sludge and slurries, air and other services. Expanding plug valve. It is complex in design. It is used to prevent product contamination, where double isolation doesn't require. It uses multiple components, allowing the plug valve to expand mechanically, and give it a true double block and bleed function in one valve. Expanding plug valves are often used to prevent product contamination. Advantages of plug valves. This valve opens and closes fast, provides a dependable leak-tight service, offers minimal resistance to the flow. Disadvantages of plug valves. Need a higher amount of force to operate. A pressure drop is encountered due to reducing port. Actuators are required for larger valves. Pinch valve. A pinch valve is a flex body valve with a flexible pinch tube that can be pushed together mechanically through a mechanism or through fluid pressure to create a full closure of the flow path. This pinch tube is made of normally rubber, and in this, we can turn the valve on and off using the pinch mechanism. The flow passage of these valves is straight without crevices and moving parts. Pinch valve is ideal for handling slurries, solid materials and liquid with suspended solids. Types of pinch valves. The pinch valves are generally of three types: normally open pinch valve, normally closed pinch valve, changeover pinch valve. Normally open pinch valve. This valve is in open condition at the non-pressurized state. To close the valve, the pressure is inserted over the rubber sleeve to induce the pinching effect. This valve operates on two kinds of pressure forces: fluid pressure force and air pressure force. Normally closed pinch valve. This valve is generally closed at the non-pressurized state. The closing operation is performed by the spring element, which forces the pinch element to be closed at normal conditions. The operating force of this sleeves is done by spring force, fluid pressure force and air pressure force. Changeover pinch valve. This type of valve incorporates dual channel operation, which means its half part is made normally open type, and another half is made normally closed type. The changeover between the both can be done anytime by sliding the changeover nut. The force includes spring force, fluid pressure force and air pressure force. Advantages of pinch valve. Highly suitable for abrasive or corrosive media. Less friction and turbulence inside the valve. Easy and cheaper to maintain. Disadvantages of pinch valve. Not suitable for high temperature application due to the elastomeric feature of the sleeve. The rubber sleeve can collapse due to high pressure difference. Not advisable to use for vacuum applications. Pressure relief valve. A pressure relief valve is used to release excess pressure from a system during overpressure situations, thus preventing catastrophic failure. It is used to help improve safety. These valves are spring automated and will help to return a system to the desired pressure during overpressure events. Types of pressure relief valve include spring-loaded pressure relief, balanced bellows and balanced piston valve, safety relief, pilot-operated pressure relief, and power-actuated pressure relief. Advantages of pressure relief valve. It is versatile and can be used in many services. Most reliable if properly sized and operated. Disadvantages of pressure relief valve. Susceptible to chatter if built-up back pressure is too high. Relieving pressure is affected by back pressure. Diaphragm valve. A diaphragm valve used a diaphragm for its opening and closing. The valve doesn't have a valve disc. It is a linear motion valve, and it can be used to start, to regulate, and stop the fluid flow. The diaphragm is connected to the compressor with the help of stud, which is molded into the diaphragm. If the valve is opened, then the diaphragm is lifted out of the flow path and the fluid will flow. Types of diaphragm valve. The diaphragm valve are of two types. They are weir-type diaphragm valve and straight-through diaphragm valve. Weir-type diaphragm valve. Weir in the flow passage is designed to reduce the flexing of the diaphragm to a minimum level, but it still provides a smooth and streamlined flow passage. Weir-type diaphragm with the rising stem. The hand wheels carry a shroud that covers the stem threads, while sliding over a lift indicator sleeve. Straight-through diaphragm valve. This type of diaphragm valve requires a more flexible diaphragm than the weir type. Due to this, The construction material for this type of valve is restricted to elastomers. This type has high flexibility and large area. They are available with full bore and reduced bore flow package. Advantages of diaphragm: high corrosion and abrasion resistance. Leakage of steam is eliminated. The construction is simple and they are easy to operate. Disadvantages of diaphragm valve: hydrostatic pressure is limited by the diaphragm. Full drainage is prevented by weir type. They cannot be used for high temperature and pressure.